Hello students, welcome to EPG Pathshala. I am Monica Saini from Department of Anthropology, University of Delhi. Today I am going to discuss on the module Determination of Time of Death through Studies of Bone and Skull under the Forensic Anthropology paper. After studying this module, you will be able to define and distinguish between the causes of death and manner of death. You will be able to determine the manner of death and the identity of the deceased. In addition, students will be able to describe the various anthropological tests that can be done on skulls to help in identification. The estimation of age at death is an essential part in the reconstruction of population demographics and the individual analysis of human remains. Forensic anthropology is a specialty within physical anthropology. Forensic anthropologists, they work with the skeleton to determine the identity of the deceased. They often work with forensic pathologists and forensic odontologists to help determine the cause and manner of death and the post-mortem interval or the length of time since death. Anthropologists can often tell the differences between an ancient and modern skeleton by the context of deposition. This includes the location, position, and condition of the body, and it gives clues to the event which led to its burial. Forensic anthropologists, they recover human remains, identify human remains, and determine time or cause of death. Associated material evidence can also suggest the origin of a set of remains. Through the study of bone, an array of information can be ascertained regarding the remains, including but by no means limited to age, gender, ethnicity, cause of death, and even indications of lifestyle such as where a person might have lived. The adult human skeleton consists of some 206 individual bones, with there being even more in the skeleton of a child whose bones have not undergone certain fusion processes yet, and many of these bones may prove useful to the anthropologist. Now you will be studying what is the significance of age estimation. The estimation of age at death is an essential part in the reconstruction of population demographics and the individual analysis of human remains. After a person has reached adulthood, approximately 25 to 30 years, bone have stopped growing. Changes to the bone are more subtle and there are fewer places on the skeleton where changes can be directly related to the age. Other clues as to the age of skeletal remains may make an estimation of age possible. There are practical, criminal justice consideration out the age of bone. This means that when reliable knowledge about the age of bone remains, this must be taken into account when deciding if it is forensically significant. The determination of time of death is anthropologically helpful if soft tissues have decomposed. But if soft tissue is present, identification can be done by the pathologist. Now I will tell you what are the different stages of decay. First, let us look at the early stage of decay. The flesh of the body goes through 5 stages. The first stage consists of the mortis phase. In this phase, The blood is not being pumped through the body, so due to gravity, it pools in certain areas, and this is known as livor mortis. Shortly after this, the muscular tissue becomes rigid and incapable of relaxing, a state called rigor mortis. Next, the body loses heat and cools in a process called algor mortis. Second, the body goes through bloat, which means that microbes are rapidly growing and forming gases within the body. This is also usually when bugs and insects begin to feed and reproduce on the remains. In the third stage, there is rapid loss of mass due to insect feeding and natural purging of fluid due to decomposition. Advanced decay is the fourth stage, and there is little left of the body at this point. Finally, the last stage is skeletonization, when no flesh remains. Although bones change throughout life in response to activity or inactivity, it also changes with aging, disease, and injury. There are definite intervals during which bones are actively growing. Once they have reached maturity, the bones will not grow except for repairs and reaction to aging. Thus, the mechanism by which the age at death is estimated are different for people who die while their bones are still growing, as in the case of subadult, compared to those whose bones have stopped growing, as in the case of adults. The age of death can be determined from dental eruption, bone size and maturity, epiphyseal closure, third molar root, sacral segments, pubic symphysis, cranial sutures, sternal rib, and periauricular margins. Next, I will tell you how the age estimation is performed by forensic anthropologist. A number of methods are used to estimate the age at death of an individual from his or her skeletal remains. The most common methods used to estimate the age of subadults, that is, individual under the age of 18. They are bone formation and growth and dental formation and eruption. Among the most common methods used to estimate the age of adults are cranial suture closures, changes to pelvic bones, and tooth wear. It is easier to estimate the age at death of subadults because growth occurs in a known pattern. Age estimation is not an exact science. Age estimates are usually expressed in a range of years. For example, this individual was 40 to 50 years of age at the time of his death. Now you will be knowing how bone development is used in the determination of age. Bones also have definite phases of growth that are age dependent. When the long bone starts to grow, they consist of the shaft or diaphysis and the end or epiphysis. As the individual develops, these two fuses together at the growth area called the metaphysis. Within the metaphysis is the epiphyseal plate or growth plate, which lengthens as the immature bones grow. When the union is complete, growth ceases and what remains is a thin line at the growth area called the epiphyseal line. The union is not an event, it takes place over years. In general, union of individual bones takes place earlier for females than males. The clavicle in the shoulder has an epiphysis that fuses in women between the ages of 17 and 21, but in males, the union takes place between the age of 18 and 22. Next, you'll be knowing how human skull is used in the estimation of age. There are some ossificatory processes of the immature skull which are useful in ascertaining the age of individual at death. Though the use of suture closer to designate age has been challenged in recent years. This criticism is based on the evidence of high intragroup variability, yet in a large number of cases, this procedure is reliable. The frontal bone at birth consists of two halves, which usually begin to unite in the second postnatal year. However, in certain proportion of cases, this medium frontal suture or metopic suture may remain open throughout the life, thus demonstrating the phenomena of metopism. The occipital bone at birth is in four parts: the upper part, two lateral portion, and a basilar part. The upper portion unites to the lateral portion by the end of the fifth year. The lateral parts join the basilar part before the seventh year. Later on, the basilar part unites to the sphenoid bone by a strip of cartilage up to the 20th year. The closure of the basilar suture clearly demonstrates that the skull is that of an adult. The sagittal suture, which is the squiggly line that runs the length of the skull, it notifies whether it's completely fused. If it is, the remains are likely to be of someone older than 35. The coronal suture, it fuses by the age of 40 years. The suture at the back of the skull, that is lambdoid suture, it begins closing at the age of 21, and by age 30 it will have closed. By about age 32, the suture running across the top of the skull, that is sagittal suture, back to the front will have closed. By about age 50, the suture running side to side over the top of the skull near the front, that is coronal suture, will have closed. Dentition in age determination. The eruption of the temporary and permanent dentition is a much better guide to the age of the individual at death. The sequence of both deciduous and permanent tooth eruption is quite consistent because the teeth erupt in a stated order and at average ages for each tooth. This sequence is substantially the same for both sexes and all races of modern man studied so far. As such, sexual and racial variation in the age of the eruption of teeth may disregard in attempting to age specimens. The following table is showing you the usual ages of teeth eruption. First, the lower central incisors erupts as the age of 6 to 9 months. The lower lateral incisor and first molars appears in the age of 15 to 21 months. Canines erupts at the age of 16 to 20 months, whereas second molars, their eruption takes place at 20 to 24 months. When we talk about the permanent dentition, the first molars, they comes in the age of 6th year. Central and lateral incisors, they appear in 7th or 8th year respectively. Second molars appear in 12th year to 13th year. And finally, the third molar, it appear in 17th year to 25th year. The next source which is used in age estimation is vertebrae. The neural arc join the body or centrum of each cervical vertebra at about 3 years of age, each thoracic and lumbar vertebra at about 6 to 7 years. The epiphysis of the centra or annular epiphysis appear at puberty and it generally fuses by 20 years. Union of the sacral vertebrae is completed after the 25th year. Degenerative pathologies, for example, spondylitis, arthritic symptoms, and exostosis are likely to appear after 25 or 35 years of age. Next, you will be studying how pubic and rib bones can be used in the determination of age. The main areas in the body where age determinations are made in adults are the pubic bones and rib bones. In adults, there are several ways of determining age at death. One of the most common method is the microscopic observation of the condition of the pubic symphysis. The left and right hip, that is the pelvic bone, join at the pelvis. Where these join, there is a symphysis or space that has small amount of cartilage. When the cartilage is removed and the bones are separated, the shape and the surface texture on the medial or inner surface can be examined. These portions of the pelvic bone change in a predictable way as a person ages. This surface is rough and beloved in younger adults, but by age of 35 years, the surface becomes increasingly smoother and develops a rim. After the age of 35 years, the symphysis steadily degenerates and the surface begins to erode. The older the person at death, the more enough and uneven these bones will be. Forensic anthropologists will compare this against a database of standard markers to learn the age of the skeleton. Check if there are any soft marks on the cartilage which are left by childbirth as the bones soften to allow easier birth. The rami of the ischium and pubis united at about 7 to 9 years in males and 5 to 7 years in females. Union of all three segments in the acetabulum is usually complete by about 16 years of age. In addition to the pubic symphysis, the ends of the ribs that meet in the front of the body, that is the sterna end, also change as a person gets older. Examine where the ribs join the sternum. This is also a good indicator of age. A forensic anthropologist will compare it against a database of standard markers and it is often more accurate as it is not a weight-bearing bone and remains unaffected by childbirth. Now you will be knowing the wrist in the ascertainment of age. The wrist as bone often hold clues to primary work of the descendant. Bony ridges form where the muscles were attached and pulled over the ears. A forensic anthropologist might find a bony ridge on the wrist and decide the dead person may have been someone who used their hands for a living, such as a chef or seamstress. The figure is depicting you the different stages of development of the wrist bone from 6 months to 8 years of age. Long bones in age estimation. The head of the femur fuses with the neck at about 14 to 15 years in females and 18 to 19 years in males. The head of the humerus fuses with the shaft at about 17 years in females and 19 to 20 years in males. The olecranon process of the ulna appears in both sexes around 11 years of age. Fusion is complete in females around 15 years of age, while in males it is complete around 17 years. The age order of the union of epiphyses has been determined accurately by Stevenson on the basis of large series of skeleton of known age. The sequence is definite and consent for men irrespective of sex and race. The following table is showing you the age order of epiphyseal union in men. The distal extremity of humerus, it begins the beginning of union of epiphyses in the distal extremity of humerus begins around 15 years and it gets completed by 17 years. The coracoid process of scapula fuses around 15 years and this fusion gets completed before 16 years. Three elements of innominate, the fusion begins around 15 years and it completes before 17 years. The distal extremity of tibia and fibula, the fusion begins around 18 years and it gets completed at the end of 18th year. The ramal epiphysis of pelvis, the fusion begins around 19 years and it completes around 22 years. Thus, it is clear that the estimation of chronological age at death draws upon a wide range of observation. However, it depends for its accuracy on the verification of sex on account of developmental precocity in the female. Besides, there is a variation between population in the skeletal manifestation of chronological age due to genetic as well as nutritional and other environmental differences. Now, you will be knowing how isotopes are used in the age estimation. Bones and teeth are usually subjected to isotopic analysis in cases of dating skeletonized human remains, though if present hair and nails may also be used. Establishing the age of a set of remains, as in how long ago the individual died, is often a difficult task. With more recent set of remains, there may still be some tissues present on the body to help in pinpointing the age of the body. Certain soft tissues and ligaments can last for up to 5 years. So, the presence of these may at least be able to narrow down time since death to the last few years. Typically, isotope analysis can prove to be particularly beneficial in establishing the likely age of remains. Among the most common elements to be studied in isotope analysis are carbon, nitrogen, oxygen, strontium, and hydrogen. This branch of study, which can be focused upon unstable or stable isotopes, is based on the principle that many elements within the body exist as various isotopes, many of which are taken into the body by eating. Despite the benefits of this technique, it is not as accurate as would be ideal, and establishing time since death using isotope analysis can only allow for an estimation. However, it must be taken into account that exposure to certain conditions can affect the isotopes present in a sample and the ratios of these isotopes. Furthermore, isotopes are ubiquitous in the environment. Thus, it is entirely possible for detected isotopes in a sample to actually be the result of contamination. So students, let us summarize. Bones are live and carry on all life functions. The conditions of bones can tell investigators about a person's health and nutrition during life. The identification of factors differentially expressed in fusing sutures that has led to multiple targets for future research. The age of a person at death can be estimated by analysis of a number of bones. During life, many of the 450 bones a person has at birth grow together. Finally, it fuses and form 206 bones. As the cartilage between them is replaced, an epiphysis line is visible. When the cartilage is fully replaced, the line is no longer visible. This information can be used to approximate a skeleton's age. When the skeleton is first discovered, then take the samples from around the remains, including any bugs you come across. Insects such as blowflies have a very distinct lifestyle and often plant their eggs on newly deceased bodies. By identifying the stage of the life cycle of bugs, a near exact time of death can be established. This science is known as forensic entomology. Finally, it may be pointed out that the determination of age at death from the postcranial skeleton is quite difficult in mature individuals. However, the most reliable indicators are the face of the pubis symphysis, certain features of the scapula, and closing of sutures. Thank you.